So I like to learn by doing and learn by teaching. Hence I created this video because I wanted to learn really how these agentic large language models work, how local large language models work, and these deep research applications that you see online. They're really interesting to me. I've been using them a lot. And so combining all three of these, I've created my own deep research application that runs locally on my laptop using an open weight model called Qwen3-30b-a3b. Over the next 20 minutes, I'm going to run this, show you the deep research application that I've created, the results that not only the results that it produces, but also a little bit about how it works, how it was architected, how I designed it with an invariant-first approach in order to follow a specific workflow, and ultimately, just kind of explain how this is working all along the way here. So compared to a lot of the other models, if you imagine like an OpenAI model or a Gemini model, if each one of these circles represented 1 billion parameters or 1 billion artificial neurons, a lot of those models have 500 billion artificial neurons, whereas the model I'm using is much smaller. It's got 30 billion parameters, which is represented here by these 30 circles. But when you give it a prompt, actually only 3 of these parameters are activated. So that might lead you to wonder, how can such a small model lead to, for example, a 13-page report that's formatted and well-researched and well thought out and well-reasoned and all of that? And the answer is, I take the research problem itself and break it down into smaller pieces and then agentically orchestrate between those individual pieces. So let's just fire this up and run it here. I'm using LM Studio to host my model. And again, my model is Qwen3-30b-a3b. So let's load that into memory. As I'm running this, if you keep your eye down here at the bottom of this window, you will be able to see the token streaming live. But you also can just look at the custom web page that I created here, which will show it in a better format here. So what's happening right now is I have a few high-level agents at work. One is I have a deep researcher orchestrator agent, and these are color-coded, that will realize I did not provide it a topic yet, and I could have actually provided a topic by passing in a query parameter like weather or the Titanic, but because I didn't do that, it realizes, okay, I don't have a topic, so I need to understand what to do next, and I've taught it to invoke the Clarifier Agent. And the whole purpose of the Clarifier Agent is to be really good at getting a topic from the user that's really clarified and structured in a way that's good for performing research on. So the Clarifier Agent takes over control, it does a little bit of thinking, and ultimately it'll invoke a tool, which is the user input tool. So let's give it something interesting here. Let's say, tell me about the latest advancements in LLMs within the past 30 days. One reason why I give it this query in particular is because there's a knowledge cutoff with Qwen3, which is October 2024. And so I also taught it, if the query is in any way could be possibly relevant beyond its knowledge cutoff, then the very first thing it should do is use its search tool just to get some general context, so that if it needs to ask me clarifying questions, it has more well-informed clarifying questions that it could ask me. So here it should have use its search topic context tool, which looks like it did, and it's now going to come up with some clarifying questions. This tool right here that I went past real quickly was the topic assessor tool. This tool is intended to determine, is the topic well specified enough? Is it clear enough in of itself to begin research or not? The vast majority of time when I give it a 1 or 2 sentence research query, it is not clear enough, and I taught it to do that. It really needs to be really highly specified in order to perform research, and that's what it'll guide me through right here. So it says the next step is to generate clarifying questions using the clarifier tool, and it's doing what is called an outline-based clarifier. And the outline-based clarifier works like this. Basically, it's going to take the query that I gave it, and it's going to pretend it already has all the knowledge already in order to produce a summarization outline. This feels like it's kind of out of place, but there's a big purpose to this. By coming up with 4 different summarization outlines, hypothetical outlines, it could then look at the 4 of them and understand what's different about those 4 different outlines. So these should be 4 different flavors of outlines. And then what it's going to do is it's going to come up with 4 questions, but it's not going to come up with 4 arbitrary questions. What it's going to do is come up with 4 questions that I would need to have answered in order to determine which one of these outlines would actually be best for a summarization. And actually, I don't use those outlines later on, but the whole point of like this whole process is to force it to use some sort of deliberate thought process rather than arbitrarily coming up with clarifying questions. So you can see the clarifying questions that I came up with. It says to help refine the research, please answer these questions. Should we look at specific models? I'll say no, look at open weight models. And you know what, let's just skip through this and say the report should only be 3 sections long. I do that for the sake of brevity. This report, if it goes on too long, or if it's a large enough report, it can take upwards of 30 to 40 minutes. I just don't want to record a video that long. So the next step here for the clarifier agent is to take the original research query that I gave it, the clarifying questions and the answers that I just gave it, and more or less try and come up with a final research query in 2 passes. The first pass, it'll take a shot at, okay, what should be the final research query, trying to maintain the original intent behind both my answers and the original query. I then ask it to reflect on itself and critique that draft, and then to produce a real final query with applying, the criticisms of its first draft. And then once it's gone through that, we should be done with the clarifier agent, and we will release control back up to the high-level orchestrator here. Okay, it looks like it was done with the clarification. It looks like the final topic it came up with is provide a concise overview of major advancements in large language models from the past 30 days, organized in exactly 3 sections. And it looks like it's actually opinionated on what sections that is. It's interesting. We'll see how that shakes out when the summarizer agent picks this up. But anyway, the clarifier agent's job is done. It releases control back to the high-level orchestrator. The high-level orchestrator sees that it first called the clarifier tool, and now the state is clarification complete, and now it's time to call the researcher. So now the researcher has control, and what it's going to do is come up with 3 questions and go and research those in parallel, actually serially here. It'll go research those 3 questions, gather all that knowledge, and then it'll do a step here in a moment, which is basically a reflection step. So if we look at how this is working behind the scenes here, it takes the query, it comes up with 3 research queries or 3 research questions, goes to the internet, and by that point, it'll collect a lot of knowledge. And then, as I said before, it'll reflect. And the thing that it's reflecting on is it's looking at the knowledge it just gathered so far and the final research query, and it's kind of asking itself a few questions. Number 1, does it have enough information to proceed forward with the summarization report, or is there more information we need to gather in order to satisfy the research query? Number 2, based on the knowledge that we've gathered so far, are there any new knowledge gaps that we didn't anticipate that we should probably try and plug in order to make this a good report? And then number 3 is, have we hit our maximum number of iterations? For the sake of this demo, I said we're only going to do this whole process twice. So at most 6 research queries, but in theory I can make the sky the limit on that and have a really, really deep research report going on here. One thing you'll notice back here in the background, it says processing prompt, and there's a number here. This is a percentage, and for some of these prompts into Qwen3, I like to try to add just a lot more context. So it has, I've got 32,000 tokens to work with, and the good thing about having a window that large is I can give it quite a bit of context in order to inform good research questions to ask next. The bad thing about this is if you're using most of that context window, it just increases the runtime a little bit, and that's when you see those percentage kind of slowly climb up. It is just loading that into context, and here you can see it again. It's trying to come up with more questions, and there's just a lot of knowledge gathered so far. While this is running, I could also describe how I used basically an invariant-first approach with this, and what I mean by that is behind the scenes here, there is, what do I call these, shared models? There is basically a state machine, and that state machine has a very prescriptive way for how to go from one state to another state. So for example, here we have a state where it's clarifier needs topic, and the only way to get to a clarifier topic submitted state is for a tool to invoke this function, which is submit topic. And I've taught all of this via prompting to Qwen3 how to traverse through the state machine. So even though Qwen3 isn't very large compared to a lot of the commercial models, and therefore it's not as agentically smart, by putting up these sort of constraints where I basically say, here is a constrained state machine and you have to stay within these rails, and this is the only way you could traverse through the state machine, it makes it more deterministic and more reliable with how it proceeds through the deep research process. So the other thing that I could show here is, because I'm using OpenAI's Agents SDK, I also get to use their tracing for free, which is great. And I highly recommend, if you're going to do anything that is not trivial with a large language model, use tracing. It doesn't have to be OpenAI, just have some level of observability so that you know when there's a multi-step flow where there are non-deterministic inputs and outputs coming in and out of all these things. If something's not going well at the very end, you can at least inspect, for a given one of these, what was the model behind the scenes, what was the parameters, the temperature and top P, for example, what was the system instructions, which is what I'm showing right here for this particular step, and then what was the input, the output, including the think tokens, and also what were the tool calls along the way. So this has been extremely valuable because I've run this thing so many times, and so many of those times something hasn't worked right and I had to tweak something or improve in some way. Being able to quickly diagnose that via the traces has been extremely valuable. So I highly recommend good observability for these large language models and agentic workflows. Okay, and it looks like we are moving on to the summarization step, which is great. So after the research concluded, which is this orange box, it relinquished control back to the high-level orchestrator, and the high-level orchestrator said, basically, okay, we've done a clarification, we've done research, now it's time to summarize, and that's what its internal think tokens will more or less say here. And so it then kicks off the summarizer agent. It says, okay, let's tackle this step by step. And the way the summarizer agent works is it also has its own tools. It'll first come up with an outline generator, completely ignoring the outline at the very beginning. We have discarded that. We are now generating a new outline from scratch based on the actual knowledge that we did gather. And you can see it came up with an intro, a background context, analysis of key issues, and recommendations. And you see there's 4 sections there. And it pretty reliably doesn't do a great job of creating the first outline, but then what I immediately ask it to do is to critique its outline, take into consideration the actual research query, which should mention in here, it looks like it's truncated, but it should mention in here, no, there it is, exactly 3 sections. And it should then figure out, okay, they only want 3 sections. And so ideally what we see in the output here is these sections include key technical improvements, real world applications, and emerging challenges or opportunities. So that is 3 sections. So it did eventually get back to what I needed here. But even if I didn't specify 3 sections, having this sort of self-reflection and trying the outline approach one more time is really great to make sure the report is academic sounding or not, depending on what the user really wants, or just really tailoring it towards what the query and the knowledge that was gathered so far really represents. And then we get into basically a series of section expanders. So this section expander tool should be called 3 times, once for each section. And every time it creates a section, it'll output markdown. And then every time it moves on to the next section, it'll try and pull in the previous 1 or 2 sections as context so that it can maintain narrative consistency, fluency, and just ensure it's not repeating itself too much. And again, these are all prompts that I'm sending into these tools and these orchestrators in order to get really good results here. Okay, it looks like it should be wrapping up. It says, okay, let's see, the user wants a research report. So far I've generated an outline, critiqued it, and expanded the sections. And sure enough, after 14 minutes and 43 seconds, It output almost 19,000 tokens. Actually, that's just only counting the tokens that went to the UI. I'm actually not showing a lot of the tokens internal to the smallest tools themselves, like the search tool or the outline generator tool or the critique tool. So there's probably roughly double those tokens. And you'll notice on the right hand side here, the tracing tool, it looked kind of oddly organized while it was running, but as soon as it was able to kind of finish and run its finalization step, we could see the entire process here. And actually, if I expand this out, we'll be able to see, or collapse these down, we'll see this in better detail. So again, top level, there's a deep researcher orchestrator. These generation blocks represent the part of the conversation that it was owning and figuring out what was the input and what tools did it invoke and what was its output and so on. For a given agent here, like the Clarifier agent, it also has access to its own tools. So it has an assess topic tool, clarify tool, and a revision tool. And the researcher agent, if we expand this, we see it generated initial questions, performed 3 searches, 1 for each of those 3 questions. It then reflected. One thing that you'll see in a lot of these is, let's take, for example, the assess topic tool. I had to do something kind of interesting here where this normally would be a single invocation to a large language model to say, you are a expert at, research, coming up with topics or assessing topics and determining if they need clarification or not. Now, what I wanted as output from this is JSON, and in the large language world, that means you need to click the box that says structured output. But because this model is so small, when I click the box for making the output be structured, I think how it's working behind the scenes is it's blacklisting certain tokens, including think tokens, and therefore it would just straight up give me the JSON without any thinking context. And I realized I was reliably getting much worse results when that thinking context was lacking. So what I decided to do, there are a few ways to get around this, but what I decided to do is just have a vanilla, generate the response and generate it however you need to here. And then I abstracted this into what is called a thinking agent, where the second half of that thinking agent will consume that prior response, and its goal is to turn it into JSON. So that way I get kind of the best of both worlds. I can have a lot of thinking tokens in the first half of that thinking agent in order to get a good response, and then I get structured output on the back half of that. The cost of that is, a little bit more tokens being spent, more time being run here. But honestly, it was worthwhile for me. And if you're interested in seeing some of this code here, here's my abstraction around a thinking agent. I say my 99.9% of this code was written by Cursor AI, and I was just guiding it along. So I pair programmed with Cursor AI, and we came up with this solution where you basically have a thinker agent and an output agent. And so we should have 2 run calls in here. Let's see if we can find them. So 1 run streamed call for the thinker agent, and then we should have another run call, which is right here, which formats it as JSON. So that's what that is right there. So pretty interesting. But you know what? We have the report generated. Why don't we take a look at it? Okay, so it generated a 5-page report, which is about expected if I only told it to produce 3 sections. So I'm not going to read this word for word. I'm just going to slowly and softly scroll through this, but I've been reading these reports. I mean, I've created dozens of these at this point just by testing this out, and they're pretty decent. I'm pretty happy with how these are turning out. Yeah, I don't know what else to say. Like, they're citing their sources in line. It's grounded. It's using rich text, but it's not overdoing it. It looks like it's not outputting a lot of markdown tables. I had taught it to do that a little bit, but maybe it's kind of backed off on that. But yeah, I think, was that 3 sections? I see a lot of subsections, but there's 1, there's 2, or are those subsections? No, there's 2, and then 3. Yeah, so it created a 3-section report, did what I wanted to do, and I gave it a lot of autonomy to create those subsections as well. But yeah, so this has been pretty interesting. And I also wanted to share what I would do differently if I had to do it all over again, because I will be doing this all over again, just in different contexts at work. This won't be the last agentic large language model flow I will have ever created. And so what I'm going to do next time is to make sure I build the AI judge first, like the very first thing. So what do I mean by that? I've been working on this thing for months and months. I rewrote it probably 3 times, I think, in total. The first one was very simple. The second one was a lot better, but I was coding the orchestration rather than agentically orchestrating it. And then finally, this is basically agents all the way down, including the orchestration. And I realized, in order to make sure I don't have any regressions here, I need to make sure that the prompts at each step along the way are not regressing, that they're still performing correctly. Or if I want to improve them, I have a way to improve them in isolation without having to go through the whole report all over again. And so what I'm doing here is I've created, again, paraprogram with Cursor AI. I basically have a way to say, I'm going to target this part of the deep research process, and we're going to use this specific suite of examples or this data set. We're going to say, for this given data set, run it into this part of the deep research application, and then evaluate the output based on the criteria that I provided down here. So I do this for the outline critiquer suite. What else do I do it for? I do it for the outline based clarification, the initial outline generator, the question generator, and the reflection agent and the topic assessor. So I haven't covered all of them, but this is a good way for me to, like I said, if something's not working quite right, or let's say I would have expected, this is a good one to go through. Let's say I give it a topic and I would have expected it to tell me that it needs clarification. Here I can kind of suss out what kind of examples I'd expect it to answer one way versus answering it in another way. So if we kind of look at this example here, the prompts AI or the future of technology, or compare the performance of these two models, all need clarification, whereas some of these other prompts that are very detailed and have all the right bits of information in order to proceed forward, I say no clarification is needed. And the criteria for evaluating that is down here at the bottom here, which is, in this case, it's very simple. I say, basically, did the output of this agent match whether it said it needed clarification or not? And that's all that the judge really says. And if and when these fail, I can then go in to either the prompt directly for that agent itself, or open up Cursor and say, hey, look at the terminal output here. Help me revise this prompt in order to make this test suite pass next time. And then maybe it'll pass a little bit more, or maybe the whole thing will pass, or maybe we just need to keep iterating on it in order to make it better. So if I had to do this all over again, start with the AI judges, set the bar somewhat low, then build the agents to satisfy that low bar and get everything orchestrating together well, and then raise the bar for the criteria for what would make that part of the application pass, and then modify the prompts. And maybe it involves modifying the prompts. Maybe it involves taking an agent and splitting it into two and doing a little bit of orchestration there. But that's how I would do this differently next time in order to get more effective results more quickly. Anyway, that was a very long-winded description of how this works, why it works, and how it's possible, even with small models, it's possible to get really good results. Again, this is 1/10 the size. It's about an order of magnitude smaller in terms of the memory footprint, but it's about 1/100th the size. So 2 orders of magnitude smaller when it comes to the actual number of parameters that are used at runtime when it's given a prompt. So don't wait with bated breath for the next huge model to come out. It's possible to get really good results right now, today, with small models, with sufficiently breaking up large problems into small problems and doing a bit of orchestration. So that's my explanation here, and thanks for watching.